My name again is Bridget Brett, and I'm excited to join you here as an MIT alum, both from ocean engineering for my bachelor's and my master's in management from the school as well. And just about 5 years ago, I was president of the Club of Northern California here, and I've been an active volunteer alum for the past 15 plus years. It's hard to count after there are so many. Today, I work at a company called LiveRamp. It's a data enablement platform, and we work very closely with the world's top brands, marketing agencies, and publishers. And my role is to bring our solutions into the cloud and grow our demand with our customers there for cloud-based solutions. And much more interesting than me is Surya Ganguli, who's with me here today. He's a multi-talented person, an interdisciplinarian, and you'll hear a little bit more about that. He's a renowned researcher and a professor at Stanford today. And not only is he a professor, but he's a professor across four different departments, which is remarkable. And he also has 4 degrees from MIT, 3 bachelor's degrees, mathematics, physics, electrical engineering, and also a master's in EECS as well. So I think we share that what do they say? They say I love, or IHTFP. For those MIT alumni in the room, we share that together. And for those that are investor-obsessed in the room, you'd be happy to hear that Surya also currently serves as a venture partner for A16Z, advising on AI. So he'll share a bit about what he's done there as well. So for today, we don't have much time. These sessions go rapid fire, as you have seen, so we'll do as much as we can to get to your questions as well. Please use Slido if you haven't downloaded that already. And we'll dig deep today. We're going to talk about human-centric AI. We will cover bits about neural networks, privacy, trust, cool stuff, challenges on AI, and get going. So let's get started with the practicality of where we are today, Surya. So what do you see as the most limiting today in the human AI experience, and what's driving those limitations?
You guys hear me?
Not yet. One more try, and then we'll share the mic if it doesn't work.
Yeah, now? Oh,
yes.
Okay, great. All right. Yeah, thanks, Bridget, for the super kind introduction. It's great to be here. Great to see so many MIT alums. Great to see really old friends. In terms of limitations, look, the world has changed in the last year. It's incredible. The advent of GPT-4 is incredible. But it's useful to keep in mind some numbers, right? If GPT-4 read at the same rate that we read, it would take about 20,000 years to ingest all the data that it ingested, right? The energy that it spends is in the multiple megawatt range. Our brain does 20 watts, right? So we're much more energy efficient, we're much more data efficient, right? And then it has these really fragile errors. Like all AI systems have these really fragile errors where things that fool them would never fool a human. So I think it's like a very different type of alien intelligence that's like really, really wide, but not as logically deep as us. And so it's incredible, but I think there's a lot more work to do as well.
That's awesome. How about we'll get to some cool stuff quickly then. I know we have some more to talk about later, but what's the greatest opportunity that you see today for human-centric AI?
I think what I'm really excited about is the capacity for AI to open up new windows into science and nature, right? If you think about like historic moments when technological advances advanced humanity, society, and so forth, they often involved opening up new windows in the world, like the microscope allowed us to see the microbial world. It led to the germ theory of disease. It led to better medicines and so forth. Right? AI also opens up a new window, but not a new window of scale, but a new window into seeing patterns in high-dimensional spaces and large data sets that we as humans couldn't see, right? And I'm seeing that now in all aspects of science that may not have made it out into like the startup world yet, but it's incredibly exciting. So seeing patterns in high-dimensional entangled quantum states, seeing patterns in large databases of DNA sequences that could lead to a deeper understanding of human biology, even turning AI around to look at our brains and see patterns in our neural activity patterns, to be able to decode them, to be able to decode what people are imagining, right? So I'm really bullish on the future of AI and science. I really think we're at one of those historic moments, like the invention of the microscope, where we can see new vistas that we could never see before.
One of the things we talked about a couple weeks ago, Surya, was AI doom and your opinions on that. So we're talking about the opportunity, and then you quickly were stating some of what others say. So share your thoughts there.
Total bullshit. Yeah, it's really weird. Like even like really towering scientific figures in our field have become really, really worried about like X risk and like extinction of humanity and things like that. And I think that's it's way beyond anything high enough probability to worry about, I think. There's much more proximal issues that we have to worry about. You know, climate change, threats of nuclear war. But even within the context of AI, this talk about X risk sucks the oxygen out of the room of much more proximal issues like future of work, spread of misinformation, maintaining democracy, maintaining social trust, and all of these things. I think, you know, as usual, like self-driving cars would be easy if there were no humans around. Like if you just had a bunch of self-driving cars, you could easily get it working today. It's the interaction of humans with AI that makes things complicated. And we have to, it's not going to lead to human extinction, but we do have to think more carefully about that.
So we'll think more about the personal level and how we're all interfacing with LLMs today. So we'll take that example. And I just dream of like, you know, maybe 5 or 6 years in the future when your kids are a bit older, maybe middle school age, and they're asking you, hey, Dad, like what was life like before you had an LLM to write your emails and your presentations and like tell us what that was like. So one of the things that came to mind for me is Surya, in this field, how were you first using ChatGPT? What prompts did you give it? And how do you use it today?
Yeah. So I'll tell you my first encounter with GPT-4 was not through myself, actually. I had gone out to dinner with a bunch of friends, including Sal Khan. Amr also was there, who's sitting over there. So you got this text as well. So right after dinner, Sal texted us something. And I wasn't really thinking about GPT-4 at the time, but he texted us a really nice poem about our dinner experience, like, you know, like half an hour after dinner. And Sal's a pretty creative guy. He likes writing poetry and stuff. So I didn't really give it much thought. I was like, well, that's pretty impressive. He came up with that in half an hour. And then only later, a few days later, did he tell us it was GPT-4. And that was, I think, slightly before we all had access to GPT-4. So that was actually my first experience with GPT-4, which meant it passed the Turing test with me. I thought it was Sal. But I wasn't really, GPT-4 wasn't actually in my context. And so when I got access to it, I immediately started playing with it. I just immediately did a bunch of neuroscience experiments, like psychology experiments on it, giving it logic puzzles and so forth. And I was actually quite impressed. Like, yeah, anyways, we can talk more about that, but it's probably not worth going into all the puzzles that I gave it.
Later, after the session.
Yeah.
So let's spend some time diving into your research now, Surya, on the brain and neural networks. Is there a day where LLMs maybe have the advancement where they can actually erase something that they've learned? And I'm thinking about this because it's a concern, obviously, for many around application of intellectual property.
Yeah, that's a huge area of research in LLMs, partly driven by regulation, like ideas like the right to be forgotten, the right to have your training data erased from the model, right? Governments are demanding that now. So how does a company comply? Like, how does a company prove that your training data is now erased from the model? They can't possibly retrain the model from scratch and take your training data out. So there's various things that you can do. You can try to unlearn the training data by negating the loss function and then retraining on your training data. And it's not obvious that that alone will have the model forget your training data, right? So it's going to be a cat and mouse game where the regulators are going to come up with some audits to test whether your training data is in the model or not. The companies will try to pass those audits, but there might be more sophisticated audits that could actually get your training data out of the model somehow, right? So there's going to be a really interesting interplay here, and that, just like in security and cryptography, where you have this cat and mouse adversarial game between hackers and defenders, there will be this cat and mouse game between auditors and AI companies, and it'll be really interesting to see that play out.
Thank you for that. And what surprised you so far with AI models?
What surprised me so far? I think like if you had asked me a year ago whether or not we'd have artificial general intelligence, I would have just laughed. Like I would have said, no, we're way too far from that. What surprised me is that just scaling them up and doing next word prediction enabled them to sort of learn a lot about the structure of the world such that it could create new types of text that never existed before. Like, for example, giving mathematical proofs in the style of Shakespeare. Like, I tried this out. I asked it to give me various mathematical proofs in the style of Shakespeare, in the style of like rap music, and it was really, really good at it. You know, so if you've seen the Sparks of AGI paper that came from Microsoft, if you haven't seen that, just Google Sparks of AGI, and there's tons of really cool examples in there, and I thought they were all quite interesting.
That's awesome. When we seek to understand AI models more, one of the difficulties is, of course, isolating things within those models. And I know that you talked about doing a little bit of that in your research. But like, how can we better isolate items within the models to better understand them?
Yeah, you know, it's almost like neuroscience, right? Like in neuroscience, we're faced with brains that do interesting things. It's far beyond our ability right now to understand everything that every brain can do, from flies to mice to monkeys to humans. Like, so what we do is we isolate the most interesting behavior that we don't yet understand how the brain implements, and then we dissect it to figure out, you know, what's going on, right? So I think there's going to be that level of work that has to be done with LLMs, with foundation models, to really understand how they work. And I'm actually really excited about being in academia, because there we can address scientific questions about trying to understand how they work without a profit-driven motive, and we can publish our results and make them open to the world. What I've seen, I've spent a bunch of time in industry at Google and Meta, and just 5-10 years ago, these companies were much more open. They published everything. They valued bottom-up, curiosity-driven research, and they valued scientific understanding. Now that these systems are coupled directly to economic value, the walls are going up. People aren't releasing what they're doing. But I'm actually quite excited about the open source community, which has that spirit of open source and is catching up to what the big companies are doing. They'll always be like a year behind or so. But I think this sort of collaboration between academia and open source and this push towards scientific understanding, I think is quite exciting, because it's like a new technology has fallen on our planet somehow, and we have to really figure out what it's doing. Also to improve it, to solve those problems that I stated at the beginning, right? Lack of efficiency, lack of robustness, and so forth.
So as a Stanford professor, what are you doing within your research to help us prepare for having more AI in the world?
Yeah, so we're working, for example, on explainable AI. There's also there's a really, I think, profound connection between neuroscience and explainable AI. So we're kind of working on the science of intelligence, where we're trying to understand biological and artificial neural networks together. And so, and a really fun collaboration I have with Carl Zeiseroth, who invented optogenetics, which is this technology that can shine light into the brain and make activity patterns, any activity pattern you want, be written into the brain. What we're doing is we're trying to solve the curse of dimensionality problem, where if you can write anything you want into the brain, what do you write in and for what purpose, right? So what we're doing is we're creating these closed-loop biological intelligence, artificial intelligence systems, where we use an AI system to model neural activity from the brain, and we get a pretty good model of the dynamics of the brain. Then we understand our model, right? Then we do control theory in our model to figure out, well, if I wanted to have the brain do something, how could I get the brain to do it? Well, I do the experiment on the model. We know we use backpropagation through time and control theory to figure out what to inject into the model to get the model to do what I want. And if the model's a good model of the brain, you can inject that same signal to the brain to get it to do what you want. So then you can get the brain into really interesting clinically relevant states through this closed loop AI, artificial intelligence, biological intelligence interaction. And so we have a big grant from the NIH to work on that. And I'm actually really quite excited about that. So it's like you learn an AI model of the brain, you figure out how to explain it, and then with that understanding, you figure out how to control the model and then control the brain. So I think that'll be super fun.
That's awesome. Now to an audience question, and then we'll go back to some others. Are there any basic societal rules or restrictions that AI development and usage should follow? And the person was thinking about Isaac Asimov's Basic Laws of Robotics.
Oh, yeah. Yeah, I was a big Asimov, still am a big Asimov fan. I think those 3 basic laws are like a good start, but they're nowhere near enough of a detailed prescription for how these things can lead to a flourishing society. By the way, just as an advertisement, we're exploring these issues in an AI conference that I'm organizing at Stanford this Tuesday actually, on New Horizons in Generative AI, Science, Creativity, and Society. The societal aspect is exploring what will happen when you have multiple AI agents and multiple humans interacting in a society, and what the unintended consequences could be, and how we might try to control or constrain these unintended consequences. So we have future visionaries coming in from Microsoft. We have researchers working on AI agents in societies. We have people working in democracy, like all coming together to explore that. These are major open questions. We don't know the answers, but we kind of have to have the discussion in a really open way in a democratic society, so that like the limited number of companies that can build these large-scale devices don't determine for us how we live. Ultimately, I'm a true believer in democracy, and only in a democratic society where multiple competing interests come together to decide how to regulate these systems, decide how to control them, can we ensure a flourishing society of interacting human and AI agents.
So our time goes quickly, but we will all be there on Tuesday if we can make it, Surya.
Oh, yeah, just Stanford HAI, just go to their event website. It'll be live streamed. You can also come in person, so you're all welcome. You're all invited.
So one topic we had discussed, quantum neuromorphic computing. Did you want to dive into that one more?
Yeah.
I think this is one of Surya's favorites, so we'll maybe end on this.
Yeah, I've gotten into a rough crowd at Stanford, the quantum optics people, where, one of the 20-watt issue, right? That our brain is only 20 watts. The reason it's only 20 watts is it's mostly analog computation. But you can say, why do we have to settle at 20 watts? Could we marry the analog computation of the brain with physical substrates that are even simpler, like individual atoms and photons? So my colleagues at Stanford can build these quantum neuromorphic computers where individual atomic spins are like neurons, and they exchange light with each other. So the photons exchange are like synapses, and they flip the spins. And I've been helping them analyze the dynamics of these systems, and we've developed like memory devices built out of individual atoms and photons that behave much better than even biological memory. And we've also come up with optimizers that can optimize complex cost functions in high-dimensional spaces by using quantum entanglement to avoid local minima and get to deeper, lower cost and so forth. So this is nowhere near ready for startup land, but it's fundamental science that's, I think, incredibly exciting, and it marries quantum mechanics and AI. And I just love doing that kind of fundamental science.
Surya is definitely an academic researcher at heart, for sure. Yeah. We'll end with one last topic, and that's trust and privacy. And I know you have a pretty strong opinion on how we move forward in the world of AI with consumer trust.
Yeah, it's an interesting question. I mean, I think, as we talked, I'm actually quite pessimistic about technological solutions to trust. I think we lost trust immediately, like well before AI was rampant, through our media bubbles and things like that. We all consume different diets of information, and so we don't really trust a lot of stuff, and we probably shouldn't trust a lot of stuff that come into our news feeds and things like that. So it might actually be an interesting setting where our circles of trust actually shrink to what it used to be before. Our friends, maybe a few like limited sources and things like that. So I think this issue of trust, we're not going to have a technological solution to it. It's a socio-technical problem, and we're going to have to figure that out. I know that people are working on watermarks that can actually give a technical solution to actually verifying the provenance of, say, images. Like this image was indeed a picture from this part of the world at this time, right? There's things like that. But I think this issue of trust is a major open question, and I'm actually quite pessimistic about it. If anyone's more optimistic, please come talk to me. I'd love to learn.
I'm sure we have some in the room. Well, thank you. That wraps our time on human-centric AI, and please join me in thanking Surya Ganguli for joining us today and sharing all his wisdom. Thank you very much, Surya.
And thanks, Bridget.